Okay, so today's class, pretty simple as per usual. So start by going over the homework, reviewing anything you had questions on. And then we will do some hacker rank problems today. And actually today we have like an extra hard problem, which I think will be, good practice for you. And then I haven't put the homework up yet, but the homework will be up very soon. Okay, so how was homework for you this week?
It was fine except for the coding bat fifth edition chapter two exercise 2.14 to 2 point
Wait,
yeah.
that should say practice it. Sorry. Yeah.
And
Mhm.
in the Discord, right? Uh it doesn't say like coding bat logic one first two row problems.
Wait, what do you mean?
It only it,
Oh, oh,
it's
sorry. I think I
yeah.
sorry. That might be the wrong. Wait, what the heck? That's weird. No, this is definitely the right one. Maybe I put in the wrong one into the chat. So did you do?
Uh I did the coding bat map one third row of problems.
Uh,
And I did like a little bit of the practice it, but like I didn't
oh,
understand.
to practice it.
Yeah, 'cause like the homework says like practice it twice, and then on your screen it says coding about logic one
Yeah, yeah.
first two.
It's okay. That's fine. If you did the practice it, that's totally okay. Like,
Okay.
yeah, yeah. So did you and manage to do the practice it?
Uh like I got to like the first three problems and then I ran out of time because my week was pretty busy.
Okay, got you. That's okay. Thank you for telling me. Just make sure you like try to catch up on it for next week.
Yeah.
Okay. Okay, perfect. Did you have any questions in the homework you want to go over? Like, you want to go over
Um
maps or nothing?
no, like I
Okay.
understood yeah.
Okay, perfect. Then might as well just go ahead and jump into the hackering problems for today. So,
Okay.
the first problem is called electronics shop. So, let's look for it together. Electronics shop. This one. Um, so yeah, basically you have a given budget and you're trying to buy the most expensive combination of these items that does not exceed your budget. So go ahead and try this out. I'll give you like 10, 20 minutes. Just let me know whenever you finish. We can review it and then we'll move on. Okay, so go for it. Let me know when you have questions and like just shout out when you're done. Yeah, yeah.
All right.
Okay. So this electronics shop problem was, pretty straightforward. They just gave you keyboards and drives, right? Both integer arrays, and you have to find the biggest budget possible without exceeding your budget, right? The biggest price you could afford without exceeding your budget. And if you can't afford anything, then you return -1, right? So all you really needed to do was parse through both the keyboards and drives arrays, and just try out every single possible combination, right? Taking the bigger number each time, making sure you don't exceed your budget. And well, just a little convenient thing I did was I started my answer at -1, just in case none of the combinations meet this criteria. Then we don't have to change our answer because it just stayed at -1, right? But yeah, this one should be pretty straightforward. So I'm glad both of you guys got it. Okay, so the next question is called Cats and a Mouse, and this one is pretty straightforward. So it actually makes up for it because the problem after that is kind of hard. So yeah. Oh, don't look that. But yeah, so cats and a mouse, pretty simple. I won't explain anything. I'll just let you guys read it. Again, ask me if you have any questions, and let me know when you guys finish. So yeah, just go ahead and get started, guys. Okay, so I think conceptually this one is pretty straightforward. I think like Bryce, you just had some issues like with the syntax, with the Java syntax, but that's okay. So for this one, they're just asking you to find whichever mouse is closer, whichever cat is closer to the mouse. Sorry, I said lazy. So they're asking you to find whichever cat is closer to the mouse, and if both cats move at the same speed, then you just have to find out which one's closer, right? Which one will reach first, or just which one's closer. So all you have to do is check the distance between x and z and y and z. Um, if x is closer, return cat A. If they're equal, return mouse, and then otherwise return cat B because it's the other cat. Um, no for loop needed. You just have to check whichever is closer, right? So pretty simple. So yeah, just let this run for a second, just like that. Okay, so you guys have been working pretty hard, so I want to give you guys a break. It's 8:13 right now, so come back at 8:20, and then we'll spend like 30 or 40 minutes doing the last problem together. So come back in 7 minutes and try to be on time. Thank you. Okay, so this is our last problem for today. It's called solving a magic square, finding or something. So it's our first medium problem. So every problem we've done so far has been easy. So we're going to try a medium problem today. Forming a magic square is just this one. So, uh-oh, don't look at that. So this one's actually kind of hard. So I'll go ahead and kind of explain it to you guys. And then you can go ahead and solve it yourself or try. So what is a magic square? So a magic square is basically any like square or integer, like 2D integer array where all the diagonals, all the rows, and all the columns add up to the exact same number. So if we take a look at this 3 by 3 that I highlighted here on the left, this is a magic square because 8 plus 3 plus 4 is 15, right? That's a row. 8, 1, 6 going down is a column, which is also 15. 159, the middle row is 15. 672, the bottom row is 15. 357, going middle down is 15. 492 is 15, the right column. And then the two diagonals, 8, 5, and 2 make 15, and 4, 5, and 6 make 15, right? So that is a magic square. All rows, columns, and diagonals add up to the same number. It's like Sudoku, I think. I don't play Sudoku, so I don't know. So anyways, that's what a magic square is. So what this problem is asking you to do is they're going to give you a 3 by 3 matrix of like numbers like this, like any random numbers from 1 to 9. And they want you to turn it into a magic square. So like, obviously, if you look at this example, the fastest way to turn it into a magic square is to change this top left 5 into an 8, and then also change this 8 into a 9, and change this 4 into a 7, right? How did I figure that out? I read through the problem and I did the problem. You guys will figure that out too. So they want you to they're gonna give you a 3 by 3 grid, and they want you to turn it into a magic square by changing the numbers inside, and they want you to return the cost of doing so. So the cost of changing the grid is basically like every time you change a number, you have to add the difference between like the number you change it from to the number you change it to. Like that becomes, you add that to your cost. So for example, when we're doing this example problem, right, we change the 5 to an 8, so that's cost plus 3. And then we change this 8 to a 9, so cost plus 1, so the cost is 4. And then this 4 into a 7, so that's another plus 3. So it's like 7. Yeah, so you can, and they show you the calculations here at the bottom, right? So this took 3 replacements. You just add up the differences and you get the cost of 7. So they want you to find and return the cheapest cost to make it into a magic square. Yeah, so they can basically give you a 3 by 3 of any numbers, and they want you of any numbers from 1 to 9. Duplicates are allowed, so it could be like 5, 5, 5, 5, 5, 5, 5, 5, 5, for example. And they want you to return the cheapest way to turn it into a magic square. So that sounds like a little overwhelming. A lot of information. So what I'm gonna start you guys off with is a little link, a website link that kind of explains what a magic square is, and it actually gives you guys hints on how to solve it, because it tells you the kind of formula for a 3 by 3 magic square, right? Because they remember in the problem they're guaranteeing that it'll be 3 by 3. So there's a formula, there's a pattern to the numbers inside the 3 by 3 magic square always. So go ahead and take a crack at it. I'll give you guys 20 minutes to go over it, and like at some point I'm gonna give you guys like a hint that'll help you guys along. But yeah, just go ahead, read the problem, ask me any questions you want, and just go for it, guys. Yeah, I would really recommend reading the website first because it helps. Like read the problem, read the website, and then go ahead and start. So go for it. Okay, so let's go over this problem. So this problem was kind of hard, right? But there's ways to do it. So as I said, the easiest way to do this problem is the most like the most basic way you can think of. It's literally to make a master grid that literally holds all 9 possible combinations of a 3 by 3 magic square. These are all the possible 3 by 3 magic squares that can exist with the numbers 1 through 9, right? So you want to store all of these, because that way, once you have all 9 magic grids, all 9 possible magic grids, you just have to, so I made an array list called costs to store the costs. And all you have to do is go through each possible magic grid in the master grid, right? And just like check the cost of each one. So like, what is that? How do you do that? You can make like a variable, an integer variable or whatever. Use a double for loop, 3 by 3, and then literally just check like the grid they give you, which is S. This is the numbers they give you. Just find the difference between like the number inside the S double array list, and find the difference between that and that same position inside the magic grid, right? And then once you do that, just add that to your cost, and then once you're done with that specific magic grid, just add that cost to your array list or whatever you're using to hold your different costs. At the very end, you just have to return the smallest cost, so you can sort your array list using a collection of that sort, and then return the smallest number. So at first, this problem seems really hard, right? And it can be. There's a bunch of different ways you can think of it, right? This problem took me a while because I like was trying to do it a bunch of different ways. Nothing was working, right? And in situations like this, it's best to remember that like simple is best, right? So this is like the most basic way to think about it. Just brute force solutioning it, right? No special pattern or anything, and this is the solution that works, right? So yeah, this is a medium problem. I think like we all got something from it today. I just kind of wanted you guys to kind of experience what a medium problem is like, because these are the types of problems you guys are going to be solving at some point, right? Okay, so before I forget, so that was the last problem for today. Thank you guys. Before I forget, I want to take a class picture. So just smile on 3. 1, 2, 3, cheese. Okay, let me pop that in the chat. Okay, and honestly, You guys worked hard today. The homework is up in the Discord channel, so I'll go ahead and let you guys go a couple minutes early. Thank you guys so much for coming today, and I will see you guys next week. Bye.